Hello, this is simply about networking protocols, and today we are talking about MACs and IP addresses. Specifications that define MACs and IP addresses, detailed description, corner cases, use cases, and all those is for MAC IEEE 802 2001. For IPv4 and IPv6, only initial specifications added. There will be much more depending on what the functionality you are interested in, but start with those two. If we simplify, MAC address specifies next device that should process Ethernet frame, except switching bridging, and IP address specifies device that should process data in the Ethernet frame. In other words, IP addresses specifying source and final destination of the data frame, that processing those data in the manner that is expected by the programs they are using. MAC address specifies device that processes frame on each stage of its transmission through the network, not subnet, but all the network. Let's talk about MAC addresses. Very simple. Each Ethernet frame contains destination MAC, source MAC, Ethernet padding. All those things are not important right now. Most often, you could see MAC addresses presented in the literature in those three manners: semicolon, dash, and dot. Since most of the MAC addresses identifying specific devices, so-called unicast MAC addresses, it is important to understand which MAC address is unicast, which multicast, and which broadcast. In documentation, it is described a little bit tricky way, but in reality, everything is simple. We are interested only in the first section of the MAC address itself. If this section is even, this is unicast. It means everything that starts with 2 zeros, 02, 04, 06, FE, unicast MAC address, no matter what is else, which numbers are used in the following sections. If the first section is odd, this is multicast. It means that 01, 03, 05, so on, till 5FF, multicast, no matter which numbers are used in other sections. And if we have all F in the address, this is broadcast address. Taking into consideration that source MAC address specifies from which station we received the packet, it is obvious that this destination MAC could contain MAC addresses of all three types. Source MAC should contain only unicast MAC addresses. Before we talk about IPv4 addressing, let's talk about mask, because this is very important for understanding subnet mask and through subnet mask addressing in IPv4 and IPv6. In Boolean algebra, there is an operation AND, multiplication of the binary values, where result contains 1 in some position only if both operands containing 1. In all other combination, it will be 0. This is used to verify that specific bits are set in specific position of the specific numbers. Thus, using this operation, we can compare that in different numbers using the same mask. As a result, we're receiving same value and can compare it. So the mask is the goal of the mask is to specify the position where we expect to have bit set to 1. Subnet mask is pretty similar to regular mask with one additional condition. It starts with 1 and contains continuous ones. You already met this description of the mask that is used like CIDR, slash, and number. This number specifies how many continuous ones in binary representation we have in the subnet mask. So /1 means 1 1, /2 means 2 ones, /16 means 16 ones, /0 means no ones. And how it used. For example, for IP address that we have 192.168.10.5, we want to define a subnet using subnet mask 255.255.0.0 or in other representation, CIDR representation /16, because each byte is 8 bits, so we have 2 byte set, 2 per 8, 16. Let's represent IP in the binary manner and mask in the binary manner. So now we have this visual representation. Everything that has length same as subnet mask length is a subnet. In this case, it specifies 192.168. Everything that is besides subnet mask length specifies hosts or with specific value specifies subnet or broadcast address in this subnet. Hosts specifies starting with 1 set in host area and ends with almost maximum value. Maximum value is specific type of the IP address. So in our case, we have subnet 192.168 and possible host 01, 2, 255, 254. Now let's take a look on IPv4 frame, IPv4 Ethernet frame. As each Ethernet frame contains destination mark and source mark that are important in this current case, not important, and optional VLAN information. Why it's optional, you can check in the video that describes simply about VLAN functionality. And Ether type 0800 defines that frame is IPv4 frame. So Ether type of the frame before IP header should be 0800, otherwise it will not be treated as IPv4 frame. Then some IP header information that is used by different protocols for different verifications, manipulations, and so on. Source IP, destination IP. Source IP specifies station that sent data frame. Destination IP specifies device that should receive data frame for processing, for any protocol or feature or program. And now about IPv4 addresses types. Again, this is very simple. Remember about subnet and host sections of the IP address. And then if in host section all bits in binary representation are 0, then this is subnet IP address. For example, for 8000 CIDR mask 8, we have subnet 8, we have hosts, they are all 0, then our subnet is 80000. Same as for 900016. But here, since CIDR is 16, subnet is 9.0 and hosts are 00, so only those two, signaling that this is subnet representation. And for tricky subnet mask /21, we will talk about it a little later, but you can see that subnet is 10.10.136, but hosts can be till 143.255. How this magic happens, I simply explain a little bit later. So, all zeros, subnet representation, all ones in the host area means subnet broadcast. This packet is destined to every station in this subnet. That's simple. Host, everything that is between subnet and subnet broadcast can be host. So every combination of the values of the host between subnet and broadcast are hosts. And for multicast, this is very simple. Only first section of the IP addresses counts. If first byte of the IP address between 224 and 239, this is multicast address. It means that any IP address that starts with 224, 225, 230, 228 specify that this is multicast IP address with some specific group address that is used again by multiple protocols, features and functions for their own need. And all 255 or all ones in binary representation, this is pretty specific broadcast address, so-called broadcast in this network, rarely used. When you meet it, you will find this information. Again, it's pretty simple. And let's talk now about this tricky subnet 10.10.136 with network mask /21. Again, Boolean algebra representation. We represent IP and mask in binary form. This is the IP, this is the mask. Everything that is equal to length of the mask is subnet. Everything that beyond the length of the mask represent hosts. Hosts address area address range is between those two values, and when we transfer them back to decimal values, we will see that this is between 136.1 to 143.254, because this byte, third byte of the IP address, is split. Partially it belongs to subnet, partially it belongs to host addressing range. What about IPv6? Well, let's check IPv6 frame. It also has destination and source MAC that are not important in this case. They also could have VLAN information and Ether type 86DD that is defined. That frame type is IPv6. It has IP info in IP header. IP structure of the IPv6 header differs from IPv4 header. So in case you are verifying networking functions that depend on information that is stored in header, check the structure of the header in the specifications first. And again, IPv6 frame contains source IP that specifies station that generated data frame, and destination IP that identifies station that should receive this data frame for further processing. So in general, if we simplify, IPv6 is pretty similar to IPv4, only much longer. The biggest difference is the types of IPv6 addresses. They differ definitely from IPv4 addresses types. There are more types of IPv6 addresses, but the most used one, the most important, and those that you will work most during the verification are following. Global starts with 2000, but again, mask is 3. So to receive full range of the global addresses, you take only 3 bits of this initial address, and everything else is host addresses that can identify specific stations. Link local, FE80. When you see FE80, link local. Multicast, FF. If you see that IPv6 frame starts, IPv6 address starts with FF, this is multicast address. That's simple. Thank you. Watch all following videos.